All right, guys. So, look, thanks for being a good audience. I know how difficult it is to listen to stuff. Teachers are, lectures are rigorous. It's only natural to get squirmy after a little while and want to get up and walk around. And, it's a lot to pay attention. The big challenge is that as a teacher, they're kind of throwing a lot of softballs in your direction. Does that make sense? They're throwing a lot of concepts at you and you're wondering, like, am I going to get evaluated on this or do I need to write it down? Or there's this rainstorm of information that's coming your way. So I'm going to try to make it digestible so that we don't run into that problem. But so let's get set up in the following way. We want to get our guide document, and that's going to contain a ton of useful commands. So let's boost that a little bit, and then we're going to try these commands because we're getting into infrastructure. And so if I can quickly review this, you guys have set up a cloud computing architecture that's going to support you. So that entails servers, and it also entails what's called Cloud9, which is an integrated development environment. So open the IDE. And the idea here is that you guys are actually able to code and create things inside of this space. The mission that we are on is to create a kind of relational database copy of the corporate data that you guys have been working with in Excel, and that comes from the MelCorp. And so we've uploaded a CSV file, which is a kind of a scaled down representation of the Excel data. Now, Excel is exceptional because it's a business intelligence environment. We can stage a pivot table. We can create graphs. We have an excellent ability to slice, dice, and certainly do endless statistics upon that data. Excel is the heart and soul of a statistician's toolkit or an analyst's toolkit. Now, that's all very good. We know that there are some computational limits within Excel. Once you get around 1 million rows, things are going to get dicey, and it's hard to get results in a fast way. Really, the Mel database, it's 700 lines, 700 odd lines long, maybe 12 columns wide. That's a perfect data set for Excel. Excel is built for that moderate to small level of data complexity. But, a big question is, well, why do we need the cloud? Why are you scaling up to a relational database? It's because that's the next level of computational power. There's a couple of advantages that the cloud gives you. One is that as you need more computational resources, the cloud can add it. The cloud is really many, many servers to begin with. So here you are, you've got, a discrete compute environment here on Amazon. But behind the scenes, there are probably more servers than you're even aware of. So we could go over to your Amazon. And if you guys type in EC2 at the top, that it stands for Elastic Compute Cluster. And if you go ahead and migrate over to EC2, and I can star that, go ahead and search for it, migrate over to EC2. And I'll just leave this sitting up here for a few minutes. I don't want to move faster than I need to. But you'll go behind the scenes and you'll see that there's actually a couple of servers that are working to support your workflow right now. Now, you guys are working with a rather small computing environment. I think there's a single gigabyte of processing power. That's probably, how many gigs of RAM are your systems using right now? It could be 3, 4, 8 times larger than what you're using in the cloud. So you may be in a position where you need to ask for more computational power. You also may be in a position where you want a different kind of processor to operate with a different grade of mathematics. So for example, you guys are utilizing, many of your laptops do not have very powerful graphic processor units. They have central processor units or CPUs. But what's great about a GPU is they're very good at handling matrix data. So they're very good at taking multi-column pieces of data, i.e. something that looks like this, and then applying a scale vector or applying a mathematical transform upon a matrix of data. That's what is happening when you guys use three-dimensional games, is basically you have large files that look just like this that actually represent all the points that need to get drawn on the screen for each of your 3D characters. So when my son, bursts into my room and is like, "Dad, check out this character. Do you guys play Singing Monsters?" You do. You're like, "Yeah, I don't. Singing Monsters. It's the coolest thing ever." I was like okay, well, one of you has the manhood to admit to playing Singing Monsters. I think, guys, if you play Singing Monsters in the presence of a woman, you'll demonstrate that you have a soft heart. Now all the guys are like Googling Singing Monsters. Now, the flip side is that the women you're trying to impress will think that you're semi-childish. You're like a gigantic 12-year-old, which is fine. Maybe that will work. But back to the story, 12-year-old son comes in. He said, "Hey, Dad, watch this monster sing a song." I mean, that's why we want our kids to be. We want them to have a heart. We don't want them to be as cutthroat as Dad just yet. Like you will be 50 one day and you will need to be a bit tougher, and you may not be able to watch, Singing Monsters at age 50, But what is happening inside the game is that these little monsters come on the screen and they play little instruments and they play little songs. And as more characters come on, the song gets more complex and there's like a little orchestra that the monsters are playing, and it's very endearing. And all I see are matrix transforms happening, because I know that these three-dimensional characters are built upon files that are called mesh files. So a 3D artist will create a mesh file, and then let's bring this up. Mesh models, and every game is built upon these things. And each of these meshes are built of points, and the points are stored in files that basically look like what you're working on right now. They look exactly like this, except for every point inside of the mesh is located at a discrete location. And when we consume the mesh, we draw the figure to the screen. Now, video games are compelling because when you guys move your mouse, it actually applies a transformation upon the 12,000 lines that are present within the mesh. Sorry, you had your hand up.
Yeah, I was just wondering if you know what the current go-to program is for 3D modeling and that kind of thing.
I'm
sure there's one in Adobe. I just don't know what it is, and I was wondering if you did.
I am not engaged in that side of the ballgame. So, for example, the Unity toolkit would be the programming benchmark for video games in Oculus. But in terms of modeling these things, I'm sure that I'm not really qualified to lecture on that. Okay. But that's what you call a 3D pipeline. So a GPU, or a graphics processor unit, will consume a file that looks like this, and that will apply a scaling vector depending upon how you're moving your mouse at the time. So maybe the eye of the game is on the floor and you're looking up at a character. Well, it's going to project the character in a unique way, 1,000 times a second, depending upon, the intensity of the game. And that's the benchmark for video games. So graphical processor units are very good at matrix mathematics, and they're built for that. Now, CPUs are very good at logic. So and, or, comparing this thing to that thing. Are they the same? Ordinal comparison or basic quantitative comparison. Is this 32 billion, is this large length number times this equal to this? Those are what CPUs are very good at. GPUs are very good at matrix transformation. So it's really a large volume of matrix mathematics operations at one point. And so the GPU, or the graphics processor unit, is kind of being appropriated by data scientists and machine learning people to take advantage of that enhanced processing capability. So the question is, does your current laptop have the ability to do very large matrix transformation? And so we look at some of the higher end Macs, and they're relatively better at it. But really what you're buying inside of your house is probably inadequate for the kind of fast running machine learning operations that are necessary. So I'm just using machine learning as an example, because the reason why you go to the cloud is because the machines that you have inside of your home or your lab are inadequate. They're running out of room, and the money that you spend, you don't want to spend, $250,000 on a machine, and then in 6 months the project may or may not get refinanced. And there's a bit of risk involved with buying heavyweight machinery. But if you all could go to the cloud, which is your capability at this point, and maybe we go to virtual servers and we book or we rent a series of servers. Let's go to our running instances. I think I'm having success in Oregon. I know some of you're having difficulty booting instances in Oregon, and I'm moving you over to Ohio. Ohio is very accommodating. So it's easy to boot instances in Ohio. I'm just over in the EC2. If you search for EC2, that's where I am right now. So this is your Cloud9 instance, and it's a server. That's the public address. Currently, I haven't configured you you haven't configured it so that it's accessible over the net quite yet. It's not hard to do. Takes a few clicks, a little training. But if you were wanting to move the MEL data set online, and you were looking to, grab adequate processing power, you'd probably have to migrate from an Excel workbench to something more along the lines of Amazon. Now, I was reading a fun article that was written by a chief leading data scientist at Nordstrom, which is that's a place where you go to buy clothes. I don't know how many black t-shirts they have at Nordstrom, but it's okay. Google Nordstrom and you'll see. You'll be like, oh, wow, they're close there. You go in there and you try them on, and you can walk around and people will talk to you, and things like that will happen. My generation, we did a lot of that. I don't know about you guys. But Nordstrom's chief data scientist was talking about the tools that she uses to study the statistical flow of inventory. You walk into a Nordstrom, it's like a 5-story building. It's like a football field wide and long of just pure inventory. And you realize that there's, I don't know how many billions are at risk when you populate a Nordstrom's full of active real, inventory. And so the data science machine learning element inside of Nordstrom is really about, well, what items are selling? What does that suggest about the demographic profile of the people inside of our store right now? And what is the amount that people are spending on average? And then what are the kind of items that they're walking out with? And they're very data-driven organizations. Now, right now, the last couple of years, especially during the time that I've been teaching 3100, the number of retail stores are compressing. Every year we're losing thousands of retail stores, and they're leaving big kind of holes in the environment. And so Nordstrom is a good one because they maintain their relevance. Macy's, Nordstrom's, these places are keeping their relevance. Now, if you imagine the complexity of managing a single Nordstrom store, and then you multiply that by maybe, I don't know how many Nordstroms are out there. There are probably hundreds of them. There's probably one for every major metropolitan area. There's probably 50 for all the big major cities in America. And then there's probably a bunch more. Let's say there are 250 Nordstroms out there. Imagine the kind of unitary complexity that goes on in that organization. And imagine the kind of the personality challenge of being a buyer for Nordstrom. I imagine most of you could put up with the complexity of being a buyer at Nordstrom. There's an intensive human element, but there's usually a quantitative element for planning the store of a Nordstrom, because we simply know the purchasing power and the numeric volume of people coming in. So we have a sense of how many items we should put out on the floor because we have a sense of the prior season's buying volume. But I'll say this, being a buyer or being the person who chooses what is going to be on the racks at a Nordstrom, and guys, I invite you to visit a Nordstrom at some point. I'm just kidding. I have a sense like, and maybe some of you young ladies need to be at a Nordstrom too. I have a sense like the girls aren't quite shopping as much. You know, they're behaving like the guys these days. They don't like to go out and shop, but that's fine. That's more of my generation, you know, retail therapy. But if you go out to a store, you realize that there's a lot of complexity there. And so there's a quantitative realm to it. There's a qualitative, there's a personality-driven realm. I imagine that most of you would be interested at that kind of buyer job. Does that make sense? And so, you know, how should Nordstrom go about managing that analytical task? You know, we can model the complexity of a Nordstrom inside of our systems by creating, you know, estimated inventory sets and taking a look at buyer behavior and, you know, studying the clusters of buyers and, classifying the big buyers from the small buyers, you know, the college kids who, you know, buy every year versus somebody who comes in and drops a couple thousand every month. You know, there's a cleavage of buyers there. But what was interesting about the Nordstrom data scientist is she was saying that largely she uses two major tools. She uses Python within the Amazon Web Services environment. And I was thinking, well, that's a good story. So I can go in there and I can have my students spin up an EC2 instance for running their IDEs. And they're basically doing the same thing that their counterparts at Nordstrom are doing that same day. The counterparts at Nordstrom are just employing a little bit more advanced training in the same area. So they probably have the same degree of statistics, but they have quite a bit more data science under their tool belts. So if this kind of stuff is intriguing to you, there's quite a vertical growth path. I'll just say you're just now on the road to learning this stuff, but it definitely should go in your resume. So let's kind of jump in. So you guys get the idea of why the cloud, why an IT infrastructure. It's really because it's instead of owning an infrastructure, which would be very upfront expensive, you guys can utilize the equivalent infrastructure and then you can deprecate or stop using it when you're ready and stop paying for it. So for Amazon, this is about half of the revenue at Amazon. The AWS component is becoming a huge profit center within Amazon. Very interesting. So enough of that. Let's move forward. So you've uploaded the CSV, and I really wanted to leave, and you've created your Cloud9. I wanted to delay. Most of you plowed through this like you could do it in your sleep. Now, this took hours to these commands. I don't memorize these commands. You know, I proof them. And I make sure that they work in the right sequence, but that's pretty standard for an IT person, you know. So I think this data so I think, you know, what you do is you kind of keep a record of the steps that you take so that you can reuse those steps at any given time. So me showing you guys commands, that's pretty typical. You know, once you have a complex protocol built or any given complexity of protocol, you want to record the steps so you can reuse them quickly. So you guys crush these steps. I think that's very good. It shows that you're not stressed by the environment. You're comfortable with this kind of work. That's what they're saying about the Z generation or the Zoomer generation, is that they're really a lot more tuned in to the tech economy than prior generations. They're really much more. So a lot of the sensitivity that I'm trying to show to you guys aren't needing it. You know, a lot of the kid gloves behavior, you guys aren't needing it. But prior generations of learners, you know, I've been doing this 20 years. Prior generations of learners are naturally pretty stressed out by this stuff. So that's pretty interesting that you guys are crushing this stuff. It's been that way for a couple of years. So what I did here is I transformed the dates into a MySQL-friendly date format. So you'll see within the MEL CSV that these dates are going to work very well inside of a MySQL database. But their original formatting was built for Excel. So you guys have done a little bit of data cleaning as you have migrated data from the Excel workbench into the cloud. And so this goes on, and actually I used to have students do it. It stopped working at a certain stage. So these days I just give people the CSV, and it works quite well. So the next thing that we want to do is we want to amend the headers on top of the file. And so we want to look at the file and say, is it easy to type employee ID, gender, date of birth, date of hire, termination date, occupation, salary, and I've changed knowledge of work to KOW. I've changed communication to little c. I've changed teamwork to little t, leadership to little l, and then I've compressed quality of work to QOW. So you need to make sure that you've done that. Do you need a minute to do that right now? You're like, cool, I get to type something. So that your top row needs to look like this. And I imagine you could probably eliminate your current top row and just copy and paste that if you really wanted to. But I think you get the idea. We're just compressing the top of the file so that it's very easily typed. Because in a minute, we're going to create a table that's going to mirror the attributes of the CSV file. So is anybody needing to do that right now? And I can pause. Yeah.
I just had a question.
Yep.
For when we're putting in the code on the top, does there have to be the space after each comma?
Not necessary.
No.
The way that a CSV works is that a program like MySQL is going to read every piece of data, and then every time that there's a column or a comma, it moves to the next piece of data. So the first line operates as what are called headers. So they're exactly the same thing as columns inside of a Excel spreadsheet. I'll say this though, headers at the top of columns inside of an Excel spreadsheet only have meaning to you. You see the top of the heading and you say, I see, that's the date of birth column. Or I see, that's the occupation column. But as you guys will do an ingest into a relational database in a moment, and it'll be easy. Don't worry about it. So I'm going to see you like, woo, getting ready. It's going to happen, but we're going to get you ready for it. It's going to be easy. What you'll find is that these headers are very meaningful to relational databases. So that the relational database will see the hundreds of rows of termination date data in relationship to that header. So the headers are really meaningful in relational databases. They are virtually meaningless inside of Excel. Excel can't see the headers unless it's doing, per se, a graph, which is a moment when it means something. So, all right. So is everybody okay with this? Does anybody want to take a minute? Speak now. Good to go? Yes. Yeah, great question. Let's say the answer is no. And so let's say I change that and you see how it goes gray right there? That means that it hasn't been saved yet and it needs to be saved. So what I do is I press Control S, goes green, and then it makes a change. So I need to have KOW, then does that sound okay? Yeah. Now, I want you guys to stop me. Don't get it. I don't want to say intimidated, but don't get lazy. Make the person teach to you. It's a lesson I try to impart to my son, who's just happy to get the homework out of the way. He just wants to get the homework out of the way. I'm like, the homework is there for you to learn stuff. It's not about knocking it out. It's about learning. Okay. So, all right. So let's go ahead. You can copy this code if you want. Let's go ahead and open up a terminal. And for some of you, the terminal's open. For others of you, you need to go new terminal. You can basically do the terminal at any type, at any point. And if your terminal shuts down, you can collapse it. Terminals are not sacred. There's nothing important about a terminal. You can make them, you can destroy them. They will create change against the operating system. And that's the constant. No matter how many terminals you open up, that you're operating against the operating system. So let's copy in. Is that, can you guys see that okay? Should it be bigger? That's good. So let's go ahead and get in there. Your password is probably simple, SIMPLE. Welcome to SQL. So here's the first thing you do. Do you guys ever see The Karate Kid? Yeah, good movie. Did you see the original Karate Kid?
Yeah.
That's the one. I haven't seen the latest one, the Cobra Kai stuff. Nothing against it, but I'm from the Ralph Macchio. That was powerful material right there. The kid from Encino. Heck yeah. So yeah, I always see myself as a little Mr. Miyagi, and I always want you to do certain muscle movement things when you get inside of a database, and one of them is show databases. And what that's giving you is it's giving you a landscape awareness. Go ahead and try it. I'm waiting for you to try it. That's giving you a landscape awareness of what's available to you. And then more importantly, it gives you kind of evidence that, it gives you a sense of, well, I made P2 last time. Remember you guys did create database P2? And if you don't see P2 there, just put your hand up real quick and we'll give you the next step. Yeah, that's good. So he's going to go, or you're going to go, if you don't have the P2 database, that's fine. Go create database P2. Now, if you already have P2, it's going to reject you. If you don't have P2, it's going to let you do it. If the database already exists, then it already exists. So just to review, that would have been inside of this document, and I want you guys to use this document. This document is a labor of love. Oh my gosh, I get so much pride off of awesome looking documents. Like, I'm so evolved. I love to make awesome, I bold this and I get the right font and So show databases. So your kind of wax on, wax off, paint the fence stuff is show databases, show tables. Use, and then what's the name of the database you need? It's P2. So you need to go use P2. And you need to do that every time you get in the environment, or else you're going to start to issue commands that are not going to work because you haven't typed 5 letters. Use P2 is necessary for you to migrate over to the P2 database. So if you don't mind, I'm going to do that. I'm going to say use P2. And so I go show tables, and there doesn't happen to be any tables there. So I find myself saying show tables a lot. So let me just pause for a moment or two and let you do that. Okay, awesome. To me, I really appreciate just having a chance to do these commands a little bit slow. I know some of you are chomping at the bit, but guess what? Everybody has a different experience. I just had somebody who asked me, hey, I got back into my Cloud9 and everything's gone. And she was looking at a screen that looked just like this. And that's partly true. The command line environments are always going to be empty when you begin. And that's an interesting observation, which is she had just typed a bunch of stuff and the screen was full, and then you come back and you're like, did I just lose all the work? The answer is you've lost nothing. And to me, I think the history command is good evidence that a bunch of stuff happened and that you issued commands and a bunch of stuff happened. But when you log back in, the command line is empty. And that's just something to get used to. So, all right. So we're moving forward. So now you've selected the database, and now things are going to start to really happen for you. So what I want you to do is I want you to copy this kind of matrix of commands on page 13. And when you've copied them, kind of give me the high sign. Now, I don't want you guys to do this big thumb in the air stuff. You guys are Southern Californians, and you communicate like this. Yeah, I think you need to cut that out. It's a little odd. Yeah, that's right. The little shaka bra, the Swahili, we cool, baby, we friends. I think that's too much energy. I think that's too animated. I think
You didn't like how exciting it was last year?
Well, I think this is not Iowa. Like, I felt myself just getting tired. This is not Minnesota. Like, this is SoCal. We, like a little wink. That's what we do. That's all we do. So let me give you a little background. And this is what it's going to look like when you do it on your command line. And I'm going to lay it in here. This is a very surgical moment, and I'm kind of delaying with my behavior because when you do a create table command, there are two pieces of information that you're passing. Firstly, you're going create table, you're giving it a name, and then you're specifying an attribute name, and that maps to the columns of the data import. So you notice that you've got employee ID, gender, date of birth, date of hire, termination dates, occupation, salary, KOW, and it's all the same case. That took a little bit of work.
Are we copying the entire code and putting it, or is it one at a time?
You're doing this whole thing. This whole block of SQL. And then copy. And I just want you to admire my handiwork. So employee ID will exist in the database as an integer. Gender will exist as a text or a character-based. Text is just raw wording. Date of birth is a date. Date of hire is a date. Termination date is a date. Occupation is text. Salary operates as a floating point. It's currency with 2 decimal points. And it can go as 15 figures. It can be a large salary. KOW is quantitative, integer, communication, integer. So the database is sensitized to different data types. The mapping of data types from Excel back to MySQL is rather weak. So dates don't map exactly. Strings may not map nicely. You need to tell the database exactly what kind of data it must expect. It has to operate this way. Also, the database is structured to immediately mirror the number of columns up here. So you could actually take that top line, copy, paste it, and then craft a create table around that. And so if you really want to be a big Nordstrom corporate grade analyst, you've got to do a little training in this area. Okay, right now I think that's the beginning of your training. That's a good place to start. And so what I want to do is I need to be in MySQL, and then I also need to be inside of the P2 database. It won't allow me to make a table anywhere else. Now, you'll notice when you're doing IT is not really about clicking. Everything is executed with clicks, but it's really a lot more theory than activity. Does that make sense? So this is what I tell my son. You may feel busy, but it won't matter unless you're absorbing the ideas and that structure of ideas. It's very easy to copy and paste stuff, but getting results, it takes a little bit of understanding the theories at play here. So it went ahead and executed, and now I can say, show tables as I always do. And there's my P2 table. So I have a P2 table in my P2 database. And then I can go describe P2. And then it gives me this kind of schema, SCHEMA, of rows, column names, data types. So let me step away and let you do that. And you can present any issues with that. I'll say something about the way that you guys are doing it. You guys are using the command line. That's more rigorous than the average person. The average person usually uses what's called a workbench. And it's a software program that will run natively on your operating system that will allow you to connect to a database over the internet, will allow you to specify columns. And it is no more complex than any other piece of software. It's extremely simple to work with a database management application, but I think it implies a certain degree of professionalism that you're going into the command line. And largely, we're doing the command line so that the folks out there, no matter what the size of your computer is, you're going to get access to it. Like the Chromebook people are my inspiration. Like the Chromebook is the most punk rock, that's an awesome system. You know, you can get, now there's very, high-end Chromebooks, but, you can get a Chromebook for $200 at a Target and get a world-class college degree. That's really good. I like for that person to get a command line. Like if you really want to be a stud, get a Chromebook for $230 at a Target, then get an Amazon account and do lots of machine learning. Like that's cool stuff. Like that's braggadocio material. So that's very good. Now you have that table and you can show the P2, describe P2. Now here's our big move. So I want you to do these next steps where I want you to go show global variables. And what you're going to do is you're going to make sure that your database has the permissions necessary to enable you to load large volumes of data. Does that make sense? So go ahead and do copy and paste these next few commands. Now I want you to copy and paste the dark commands, the bolded commands. Set global local infile to on. And what this will do is it will give your user the permission to load what are called in-files. So an in-file can be a CSV file or another file that contains lots of raw information. And so you guys are facilitating large data integration to your cloud. It's what's called a data pipeline. Can you guys say data pipeline? Yep. That's what goes on your resume. We should probably do a resume clinic where we talk about how to add this experience to your resume. You'd be surprised at how recruitment works these days. It's very digital, where keywords matter, and using certain language in your resume matters. So let's do these. And so show global variables like in-file, and that should prove that you've configured your system. Sometimes the local in-file is on to begin with, but I would just prefer to show you the necessity of doing that. Then after that, you need to exit out of your database, and then we're going to reboot it. But I want to delay and let you take the time necessary to do those steps. Okay, awesome. So what I did is I did my configuration at the command line. I showed that I did it. Then I exited, and then I did sudo system control restart. And now I'm going to log back in again using sudo mysql u root password. Simple. Okay. And now I'm going to delay and make sure everybody's got it. So what everybody did is they went and they created a new terminal. And in order to make this next command work, they're on page 15 of the document. In order to make this is the big kung fu move that we're doing tonight. Like this is the big atom bomb move tonight. And we've worked about an hour or so to get set up to do this big data transfer. And it's going to happen. But you need to be methodical. And actually, it pays you to go slow because every detail needs to be correct. No mistakes. And so we need to make sure this command, load data in file, load local data in file, that's fine. But this file needs to be, melcsv needs to be within the home Ubuntu environment folder. So what I've had people do is copy and paste that string, that location string. And I said cd home Ubuntu environment. And then they went ls, which is a listing of the local files. And you can see that melcsv is there. That's this file. And that happens to be right here. And then I confirm that that's my present working directory. That's where melcsv is located. So what's interesting is we actually need to tell, and I think you can, that's probably what you need to do. You need to be able to tell MySQL where the MEL CSV file is. And the best way to do it is to give it very explicit instructions. Because the truth of it is I couldn't tell you off the bat where within the Linux system the MySQL was located. Does that make sense? But I can tell MySQL where my CSV file is located. So the construction of the command is load data local in file. And that's a keyword. And then I feed in one single quote, the absolute path name of MEL CSV. And that's the into table P2. So I need to be using database P2. And then I say fields terminated by comma. And that's because fields are comma delimited. It's a CSV. So that's how you load a CSV. So don't copy this. Copy this. A lot of times I have students who go like this, bless their heart. And then so you can kind of predict what's going to happen because they go, oh, Mr. Bunn, your command doesn't work. Well, the command is okay, but the MySQL part, we want to avoid that. So what we're going to do is that's what you're going to copy. And so, moment of truth. Oh, it did it. Records, 748. So it did it very quickly. Query OK. So load data. So that happened extremely fast. So let me just pause and let me see how everybody's doing. That happened a little fast. That lacked, it was a little anticlimactic. Okay. Ready? There we go. So let's get back together. So how did it go? To me, I mean, this is a big deal. Like seeing a perfect import. So something you want to do is select everything from P2. And then go ahead and let that loose. Select everything from P2. Now, a system that has a fully loaded database, it's going to look like the matrix. It's going to be flying, data is going to be flying left and right because you've moved all that corporate data from MEL into your SQL server, into your MySQL. So do you have that? Select star from P2. That's the asterisk. And you can see that there's a ton of stuff going on in there. And that some of that data will look quite familiar. The roles, for example, the position. So go select everything from P2. And then another thing you can try is select count everything from P2. And therefore you're kind of surrounding the asterisk with count and the parentheses. And that's going to count the number of rows in your system, in your database thus far. So you're realizing, okay, I'm used to working with 320 odd females and 240 odd males and however many, 420 females and 320 males, whatever that was. And now everybody's in the database. SQL databases are awesome. The structured query language hasn't changed since the 70s. It is such a strong, rational, I don't want to say easy to understand, but a legible system. Programming languages have come and gone, but SQL has remained. It is the Harley-Davidson Indian of programming languages. It's so elegant, it's perfect. And it ties you to the history of computer science. I think the first SQL-driven relational database, in my understanding, it was the Oracle database, which is now it's a billion-dollar tech firm. But that was made originally in 1968 in a project for the U.S. Air Force to track all of the nuts and bolts and the components to bombers to airplanes. And so doing the complex supply chain for all of the components to Air Force jets, that was the original use case for the original SQL database. And so this ties you to a continuum of computer science, working with these systems. So count everything from P2. So I encode some of these commands. Select everything from P2. Select everything from P2 where gender is like female. This is the binning that we did. And we're just studying. You can grab some of that from the document. And so you realize, and then you could also say select count everything. And that will give you a sense of the length of all the datum where gender is like female. And you could do the same kind of thing where it says male. And so the entirety of the data set's accessible to you via the structured query language, or the SQL, the SQL. And so select everything from P2 where gender like male. So that's very good. Now this concludes the second project. So you are Studley. We're not going to go in depth in SQL until the next project. So the next time we sit down, we're going to go in depth in SQL. But it means that we're going to go back to database. We're going to do MySQL user password. We're going to get in there, select P2. Then we're going to start working with this. So here's what you're going to do. And I want to keep you on track because I got to let you go in a moment. I got 4 minutes to go. So I'm like Jordan at the buzzer. That's how I see myself, Imagine yourself richly. And so let's grab your command. And we're not going to do much with the database today. You can technically close that down if you want. So you realize the load in file command works inside of your MySQL. But the next command that you're going to do is to be done against your Linux environment. It's because there are two different servers. And so this command will paste this in. And what that will do is it will create a file called mystuff. And if you take a look at mystuff, it concludes a session of all the commands that you issued against the database. Now, you need to do this command right now in order to account for all the hard work that you've done with me. Because if you do this command later, the commands against the SQL database only respect the commands that you've done in the last few minutes. And it's based on what's called the session. So you've logged into MySQL database and you've done these commands, and now this command, the MySQL history, is what you've done since you last logged in. So it's my preference that you do this command right now, right here now, no waiting. So go back to your Linux before you leave and do this, and you're going to upload this history file to Canvas. Boom, auto 100%. That's a lot of money. That's worth a lot. Get that 100%. And then also you need to do history, the history.txt. This is what's called a redirection operator in a stream redirection operator in Linux, where it will take the output of your history command and it will stream it to history.txt, which is a file that you might already have. So let me underscore the importance of doing this right now. Ora ita. So it creates, you have a dual artifact. You have history.txt, which is lengthy, potentially. That's Studley, all the work you've done. These are high-end commands. And then you have mystuff.txt, which are high-end pro commands. And so, hey guys, just whisper. Thanks. And your next move is to download both of these assets. So you're going to go download, and that's going to go, and I would like for you to upload both of these files to Canvas. Now, don't upload the zip. So it would almost be better that you download them one at a time. So if you just go download, what do you want to do with my stuff? Save it as, put it on a desktop. That's my stuff. And then you go new file, download, save as, desktop. My desktop is very cluttered. That's how it's supposed to be. Periodically, I go and I move everything from my desktop into a folder to get the finished stuff. A lot of stuff. So the way that this ends is you're going to upload your assignment to here. Is it the next page? Nope. It's this assignment page, and you want to upload both of your files.
Both files being history and
my stuff. Yeah, both, please. And do the my stuff right now while you have the commands live. Quite the adventure.